Welcome to Psychology 311, Study Session 1, Introduction to Sensory Processing. Introduction. The brain has a lot of work to do throughout the day. There's a continuous flow of information available from all the sensory systems, and the brain must sort through the information, prioritize and emphasize components. It has to decide both how to understand what is going on and what it will do based on the information available. In this chapter, the major highlights are sensory processing, neurological thresholds, self-regulation strategies, and other terms involved in sensory processing. Objectives. At the end of this lecture, you should be able to 1. Explain the meaning of concepts such as sensory processing, neurological thresholds, habituation, sensitization, and self-regulation strategies, passive and active strategies for self-regulation. 2. Demonstrate mastering by discussing each of the above concepts through, and 3. Discuss the different levels of threshold and types of responsiveness. Pretest. 1. What do you understand by sensory processing, neurological threshold, and self-regulation? 2. Define self-regulation strategies, passive and active strategies for self-regulation. 3. What is the difference between self-regulation and self-regulation strategies? Content. Sensory processing. Sensory processing is a complex set of actions that enable the brain to understand what is going on, both inside your own body and in the world around you. It is an overarching term that refers to the method the nervous system uses to receive, organize, and understand sensory input. Sensory processing is considered an internal process of the nervous system that enables people to figure out how to respond to environmental demands based on the sensory information that was available to make the person aware of what is going on both around the person, for example, from auditory and visual input, and from within the person's body, for example, from touch, joint receptors. Two primary factors that contributed to our understanding of the overall concept of sensory processing are neurological thresholds and self-regulation strategies. Neurological thresholds. This refers to the amount of stimuli required for a neuron or neuron system to respond. When the nervous system responds really quickly to a sensory stimulus, we say there is a low threshold, and when the nervous system responds more slowly than expected, we say there is a high threshold for responding. All of us need a balance between low and high thresholds so that we notice just enough things to keep us aware and attentive, but not so many things that we become overloaded with information and feel distracted. At the extreme ends of the neurological thresholds are habituation, related to high thresholds, and sensitization, related to low thresholds. Habituation refers to the process of recognizing familiar stimuli that do not require additional attention. Dunn, 2000. For young children, habituation is essentially so they might focus their attention on the activity at hand. Without this process, children will be constantly distracted by the variety of stimuli that are present in the environment. Sensitization. Sensitization is the process that enhances the awareness of important stimuli. It is significant to development because it allows the child to remain active to the environment while engaged in play or other learning. The ability to modulate responses of the nervous system permits the young child to generate appropriate responses to stimuli in the environment. Self-regulation strategies. These are ranges of behavioral responses to sensory inputs that reflect the child's self-regulation strategies. At one end of this continuum are passive self-regulation strategies in which the person lets sensory events occur. Passive self-regulation can mean that persons miss things or feel overtaken by things that are happening around them. For example, a person with passive self-regulation might miss the visual input of facial expressions or gestures during socialization. Conversely, a person with passive self-regulation might notice everyone fidgeting in a class, and this input could compete with the teacher's lecture. At the other end of this continuum is active self-regulation strategies. People with active strategies select and engage in behaviors to control their own sensory experiences. Active self-regulation can yield more or less sensory input. For example, a person might hum or whistle while playing cards to add sensory input to keep attentive to the game. Conversely, a person might move to a quiet room while studying as a means of controlling auditory input to increase concentration. Both passive and active strategies for self-regulation can be useful and helpful to the person or can interfere with the ability to participate in daily life. Other terms in sensory processing. Eye thresholds. This refers to the end of the neurological thresholds continuum. It reflects a condition in which it takes a lot of sensory input to activate a response. We refer to this as hyporesponsiveness or hyporeactivity to indicate less responding than would be expected. Low thresholds. This end of the neurological thresholds continuum reflects a condition in which it takes very little sensory input to activate a response. We refer to this as hyperresponsiveness or hyperreactivity to indicate more responding than would be expected. Within this perspective, we talk about responsiveness to refer to the way that you respond to demands in your life. Many things can affect your responsiveness, including the demands of an activity, the characteristics of the environment, or the way that a person's self-regulation strategies affect his daily life. When your nervous system is responding too much, we call it hyperresponsive or over-responsive, and when you are responding too little, we call it hyporesponsive or under-responsive. Hyperresponsiveness or hyperresponsivity or hyperresponsiveness. The nervous system acts based on excitation and inhibition. Under typical circumstances, the nervous system receives both excitatory and inhibitory messages and must balance these competing inputs to determine an appropriate and adaptive response. Sometimes, the nervous system responses are out of balance. When those responses are larger than we would normally expect in a particular situation, it is referred to as hyperresponsive. We hypothesize about a person's hyperresponsiveness by observing behavior in a particular context. Hyporesponsiveness or hyposensitivity. The nervous system acts based on excitation and inhibition. Under typical circumstances, the nervous system receives both excitatory and inhibitory messages. I must balance these competing inputs to determine an appropriate and adaptive response. Sometimes, the nervous system responses are out of balance. When those responses are smaller than we would normally expect in a particular situation, it is referred to as hyporesponsive. We hypothesize about a person's hyporesponsiveness by observing behavior in a particular context. For example, a child who seems oblivious to her family's activities during family fun night may be exhibiting hyporesponsiveness to the movement, sounds, and visual stimuli of the family activities. In addition to considering these patterns of sensory processing, you have to also consider how each of the sensory systems responds. You probably won't have the same responses with each sensory system. For example, you might have sensitivity for sounds and yet not notice visual or touch stimuli. Although we might identify with one pattern of sensory processing, the truth is that each person has an amount of each pattern of sensory processing. You might see yourself as primarily a sensation seeker and still have some sensitivity to certain sensations. For example, you might really enjoy movement, visual experiences and textures, and be very sensitive to sounds. Summary. In this lecture, we have learned that sensory processing, neurological thresholds, self-regulation strategies are very important aspects that shape information processing in the brain. We also noted that the extreme ends of the neurological thresholds are habituation, related to high thresholds, and sensitization, related to low thresholds. Other terms involved in sensory processing were also learned, such as hyperresponsiveness and hyporesponsiveness. This is the end of study session 1. Thanks for listening.